Alright, now as we're looking through this next one, we're going to try and do two problems in this video. So keep pushing through. So we got this function. They actually give us a rate right here. He starts out slowly at 7 miles an hour, so we're going to start about here and speeds up or slows down based on how he feels. So we got to first plug in that function and see what we get. So we're going to clear all this stuff, clear this. We got x, or input t, whatever you want to say, but x is what we can type into our calculator, plus 7 plus sine of 3.1 times that input, which in this case is x. Okay, and our graph looks like we're going out to pi and we're going up to about 11. So let's change our window. So our window is going to go from 0 to 11. And the x scale, oh no, our x is going from 0 to pi. Second pi. Now how do I know that's pi? Because it's just after 3 and this is a trig function. So that's really what we're looking at. And we're counting every 0.5 on this graph. And then for our y minimum maximum, it looks like we go up to 11. And the y scale for this one, how often do we count? Every 1 unit. So our y scale is 1 unit. All right, let's graph. So that's the kind of function that we get. We start at 7, we go up a little bit, and down a little bit, then up a little bit, and then back down a little bit. So it's looking something like that. All right, sketch the graph. Check. What does the definite integral, also known as the area from 0 to 3 of v of t, represent? This area is really v of t is miles per hour. Yep, is miles per hour. It's our rate times our time. It's miles per hour times hours, which equals miles. On your diagram, draw 6 equally spaced trapezoids. So we got trapezoid, 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 whoa, trapezoid, close enough, trapezoid, and the last one, trapezoid. Will using these trapezoids under or overestimate? Well, they're going to definitely under. Why? Because these, well, actually, I don't know, because sometimes it's over, sometimes it's under. It looks like it's more often under. So I'm going to guess under. And now if we wanted to calculate that, wow, that's quite a bit of stuff. But I think that we can actually use these, we can figure out these heights and plug them in and use the shortcut formula, which you see right below, right here, where we do f of a plus 2 times f of x1, 2 times f of x2, where you plug in all those x values, and you have a and b at the beginning and end. And all the in-between ones, 0.51, 1.52, 2.5, all these middle ones, you're going to double up on. All right, so let's actually try to shortcut that and calculate it. So I'm going to clear this graph. So I'm going to do half, or 0.5 times. Okay, so now that's my function, and that's going to help me calculate these heights. So we have 0.5 times, what was the other thing that we did there? Let's take a look at this next slide again. It's 1/2 times b minus a, from a to b. So that's what we're really looking for, from the distance from, or b is the base. B is the base. So what's our base? Our base here is 3. So the function is going to be 3 over 2. So 3 divided by 2, or 1/2 times 3, times, all right, now we need all those heights in here. The first height is going to be vars, y vars, function y1 of 0.5. No, not 0.5, of 0. Plus 2 times, now we got to put in our next one. It's vars, y vars, function y1 of, now we're going to put in our first point, which is 0.5. Then we're going to add another double. So 2 times vars, y-vars, function y1. 2 times y1 of, or our function plugged in with 1, plus 2 times, and we've got vars, y-vars, function, and y1 of the next point, which is 1.5, plus, now we're going to double again, 2 times vars, y-vars, function, y1. What's our next point after 1.5? It's 2. We put 2 in here. And then again we're adding, plus double. We're still on the inside. We're not on those end edges. So this is going to be 2 times vars, y-vars, function, y1, 2.5. Now the next cool thing, we don't have to double this last one. So plus vars, y-vars, function, y1 of just 3. Close it all off. Whoa, that was a lot. Let's see what we get. Oh, syntax. Go to. What am I missing? Oh, I see. I forgot the opening parentheses. So second, insert. We got a parentheses right there. We got a, oh, I think I forgot a multiplication symbol. I did. Right here. Second, insert, and then we got times. Let's see if this will work for us. Oh man, we can't get this right. We typed in so much stuff and now we're trying to figure out where we are. So we got 3 over 2 times y1 of 0 plus 2 times y1 of 0.5 plus 2 times y1 of 1 plus 2 times y... Oh, we forgot another one right there. So right up here we got to plug in another parentheses. So second, insert, open parentheses. And we got those open parentheses, those. Alright, we should be good now. 156.05113 or 0.0511. 156.0511. There we go. Estimate the value of the definite interval by calculating the areas of 6 trapezoids, 1 decimal place. Estimate value of, by calculating the areas. Didn't we just do that? It looks like we did. 6 trapezoids. This is 6 trapezoids. Oh, to 1 decimal place. We did that. 156.05. Show this calculation can be this calculation can be made easier by factoring. Well, we kind of did that, and that's what's implying what's happening. I kind of already did that looking at the formula ahead. When you factor some stuff out, you don't have to repeat as many things, and you can just do the one calculation. So we're going to cross it out and keep on moving. What are we on here? This was 12, and we got to do 13 before we finish the video. So keep on trucking. If you need to pause the video, go take a drink of water or let drink water out of your body, whatever works for you. You are taking a long trip in a car, your odometer doesn't work, but your speedometer does. So odometer is your miles measurement and speedometer is your miles per hour measurement. Every 15 minutes, record your speed. So we got at 3 o'clock, that's 38 miles per hour. At 3:15, we got 35, so on and so on. Estimate the distance you travel between 3 and 4:45. Use the trapezoidal rule. Okay, so we got another huge trapezoidal rule. So I'm going to pause the video. I'm going to write down the numbers, and I'm going to show you what it comes out to be. And voila, it's done. And you guys are already back, and I already typed it all in. So first, take a look at this stuff here. This is what you would be doing. 1.75 represents the time from 3 hours to 4 3/4 hours. That's 1 3/4 hours. So that's 1.75. That's our base. And then 2 is just your base divided by 2, or 1/2 of your base. And then all of these put together, we look at this, and it's 38. Notice that this one, the first one, and the last one are not doubled up on, but all the others are. So pause again if you need to copy that, but I already entered it in here. This is how it would be typed in. Pause if you need to copy that. And oh, that's okay, that's enough pausing. Let's check it. Oh, I keep messing up on my typing somewhere. Where did we miss it? Oh, we got a double plus going on. That's weird. Let's delete one. 418.25. So that's 418.25. So it's saying that we went 418 miles. 418.25 miles in 1 3/4 hours. Now that does not seem to make sense, especially when you see like these low times. So I'm guessing there's something going on that we're missing. We got 1.75 times all this, and then divided by 2. Let's double check our calculator just to make sure. 1.75 divided by 2 times 38 times 35 plus 2 times 55 plus 2 times 22, 2 times 15, 2 times 40, 2 times 40, 26. Oh, that's kind of crazy. Was this estimate a poor one? You betcha. Because I know I'm missing something somewhere, but I know that this is definitely very poor. Yes. Why? Because it's only the intervals are too far apart. Are too far apart. That's why. Now, I don't think that's why I came up with this number incorrectly, but we'll double check that work as well. So let's take a break here. We're going to insert a page. So break, come back soon.